All right. So redox reactions, well, all of you have an introduction to what redox means. So what do you know of redox? What do you mean? What does redox mean?
Reduction and oxidation.
Miss reduction and oxidation reactions take place simultaneously. They,
Yes,
when reduction and oxidation take place simultaneously.
exactly. So redox literally has come from reduction and oxidation. So let's get into what reduction and oxidation means. So this is what you guys were like this is what you had worked with till last year. So oxidation means it is either addition of oxygen or the removal of hydrogen, right? And reduction means the opposite of it. So removal of oxygen or addition of hydrogen. So initially, I mean, like a lot of reactions when you burn things in air, even acid-base reactions, like a lot of compounds contain oxygen or hydrogen. So this was like a very convenient way to identify things. But as time went on, obviously there were changes made to it, like the definitions or the idea of oxidation reduction got a little more sophisticated. So oxygen is one of the most electronegative elements in the periodic table. Like it is the second most electronegative element in the periodic table. So oxidation has come to mean that addition of any electronegative element is basically oxidation. And reduction is addition of removal of any electronegative element has come to mean reduction. So it is not necessarily oxygen, but if any electron like fluorine, nitrogen, if any electronegative element is added, it is oxidation, and if it is removed, it is reduction. And on the flip side, uh, instead of hydrogen, this has been extended to electropositive elements. So electropositive, any metals, any element that has a tendency to give away electrons. So removal of any electropositive element is oxidation, addition of any electropositive element is reduction. So this from this you can clearly see what this is leading to, right? When you add an electronegative element, so let's say you have an element X, and when you add an electronegative element to it, what is happening to X? Like, is it losing electrons or is it gaining electrons?
Miss, can you repeat? I think it's losing. No, it's gaining
Gaining,
electrons.
gaining electrons because you're adding an electronegative element.
What does an electronegative element do? Like, what is the property or the tendency of an electronegative element?
It takes up electrons.
It takes electrons, right? So when you're adding an electronegative element to
Yeah.
X, will X lose electrons or gain electrons?
Lose electrons.
Lose electrons. Okay. And to this X, again, if you are adding an electropositive element, then will X lose or gain electrons?
Gain.
Gain electrons, right? So based on this, the modern definition, like now the accepted definitions of oxidation or reduction, is based on the electron transfer. So oxidation is defined on the basis of whether the element has lost electrons, and reduction is defined as when the element has gained electrons. Okay, so compounds are formed when atoms either lose electrons or gain electrons. And even if you consider covalent compounds, right? We have seen, like, you have come across polarity of covalent compounds. So basically, whether it's ionic or covalent, an element is either losing electrons or gaining electrons. Okay, so if an element is has lost electrons, then it is oxidized. And if the element has gained electrons, then it is reduced. And oxidizing agent is the element that enables oxidation. So oxidation, if it is loss of electrons, then the third party that is enabling the loss of electrons, so it has to be an electron acceptor. So if it is an electron acceptor, it can pull away electrons, and our original element can lose electrons and undergo oxidation. So that's oxidizing agent. And reducing agent has to be an electron donor. So because reduction is gain of electrons, this gain has to happen from somewhere, right? Like if we are reducing X, if X has to undergo reduction, it has to gain electrons. So X has to become X minus. So where does this extra electron come from? So reducing agent is an electron donor. So the substance can be a compound, it can be an element. So substance that enables reduction. So substance that provides electrons so that this reduction can take place. Provide electron matlab it's an electron donor. Okay. All right. So some practice based on reduction and oxidation. So first reaction, can you identify what's happening? Is it reduction? Is it oxidation? And like which element
Oxidation.
is undergoing reduction? Which element is undergoing oxidation? Yeah, Mayas?
Sodium, oh sorry.
It is oxidation and sodium is getting oxidized. No, oxygen is the oxidizing agent.
Oxygen is the oxidizing agent. Awesome. Oxidation is taking place. Awesome. And you also identified that sodium is undergoing oxidation. Awesome. Okay. So imagine this. Sodium is
You have a
undergoing
reducing reaction.
oxidation, and oxidation is loss of electrons, right? Oxygen is the oxidizing agent. That means that the electrons that are lost has to go somewhere, right? Which means that
Yeah,
something
so
else is undergoing gain of electrons simultaneously. So can you identify which is the reduction part of it in this reaction?
ma'am, I'm sorry. I think I lost you, or was it same?
I'm also unable to hear you.
Okay.
Yeah, you.
Yeah. So what I
Yes,
was
your
saying
voice is getting like it's stopping somewhere.
oh, okay. So what I was saying is, so Myers has identified that sodium is getting oxidized. So this is oxidation process. Oxidation is loss of electrons, right? Which means that these electrons just can't disappear off somewhere, right? So these electrons have to go somewhere else, which means that another element,
Reduction is also taking place.
yeah, is gaining electrons. Reduction is also taking place. So can you identify uh, where reduction is taking place in this reaction?
Oxygen is being reduced and sodium is the reducing agent.
Yes. Okay. Now, because when we start defining things in terms of loss of electrons, gain of electrons, um, you can't look at oxidation and reduction as isolated. They always happen simultaneously. So if you have an oxidation reaction, there is always something else getting reduced. And if you have a reduction reaction, there is always something else getting oxidized. All right. So next, can you identify the oxidation reduction process in this? The second one.
MnO4 minus is getting reduced.
MnO4 minus is getting reduced to Mn2 plus, okay. And oxidation,
Ethanol,
ethanol getting oxidized to,
ethanoic acid,
yes. So what is the oxidizing agent here?
MnO4 minus,
Yeah, so MnO4 minus is the oxidizing agent, and the reducing agent,
Ethanol.
ethanol is the reducing agent. Awesome. So similarly for the third one, Ansh, Ansh Gupta, yeah. Ansh, I see your mic is on, but I'm not able to hear you.
Hello.
Yes, now I can hear you. Yeah.
Hello.
Hi, Ansh. Yes. Can you identify which is reduction, which is oxidation?
Hello. And carbon is getting oxidized and lead is getting reduced.
Is lead getting reduced or lead oxide getting reduced?
No, lead oxide getting reduced. Yes. Sorry.
Yeah. Okay. Awesome. So oxidizing agent,
On lead oxide.
this is the oxidizing agent, yes. And reducing agent,
Carbon.
yes, carbon is the reducing agent. Okay. So another thing that you guys have to remember is whatever process is taking place is always happening to the reactants. So lead oxide is the one getting reduced to lead, and carbon is getting oxidized to carbon monoxide. And oxidizing agent, reducing agents are also in the reactants only, because these are the ones enabling the process to take place now. So you won't find them once it has ended. Okay, awesome. Now comes the concept of oxidation number. So ionic compounds may, it is pretty simple and straightforward that you have direct transfer of electrons, like an element is outright losing or outright gaining the electrons. Okay, but in covalent compounds, electron transfer does not take place, like covalent
Miss,
compounds.
I can't hear you. I couldn't hear you.
Hello. Yeah.
Yes, miss.
Hmm. So I was saying,
Hold on.
yeah, ionic.
Hello.
Hello. Yes. So I'll repeat it again. Ionic compounds may, it is pretty straightforward that element is either losing electrons or element is gaining electrons. So there is complete transfer of electrons from from within the element to outside, or from outside to within the element. But in covalent compounds, you don't have electron transfer. Electrons are being shared between two different atoms. So it's not like they're completely shifting to one atom or the other. Of course, like depending on the electronegativities, there is shift of electrons, but end of the day, it is still being shared between both these atoms. Both the electrons belong to X as well as Y. Okay. So, but due to differing electronegativities, electron density shifts slightly towards one atom. So, oxidation number is used to keep track of these electron shifts. So, even though both the electrons are being shared by both the atoms, um, depending on where the electron is shifting, like let's say X is more electronegative and the electron density is shifting more towards X, and Y, like it is shifting away from Y. So we know that Y gains a delta positive and X gains a delta negative, right? So to keep track of this electron shift, you can use oxidation number. So oxidation number gives you two bits of information. One is whether the electron density is shifting towards or away from the atom, and second is how many electrons is it are is the particular atom losing or gaining. Or losing, gaining is a wrong word to use here. So how many electrons is the particular atom, um, how many electrons are getting shifted away or towards it.
Miss, can you repeat the explanation of oxidation number?
Yeah, can you repeat again?
Yeah. So oxidation number is basically a hypothetical number, but it still gives you
Miss,
a
I couldn't hear you. Your voice just stopped.
hello, hello,
Yes, miss.
hello. Yeah. Okay, I'll take an example and explain this. So we know HCl, right? Now, concept of oxidation number is basically this is a hypothetical number. It is used to keep track of electron shifts. Okay, so oxidation number is assigned, like if we have HCl, we say that oxidation number of hydrogen in HCl is +1 and oxidation number of chlorine in HCl is -1. So even though oxidation numbers look like charges, the way we assign Na plus, right? Na is +1. In this case, it is meant that Na has lost one whole electron. But in the case of covalent compounds, this +1 does not mean that H is losing an electron, because HCl end of the day is a covalent compound and both the electrons are being shared between H and Cl. But then, because chlorine is more electronegative, these electron tends to shift more towards chlorine than, and away from hydrogen. So that is the reason dipoles are produced. This has a delta positive and this has a delta negative. So oxidation number, important things to remember about oxidation number is that one, they are uh, they are hypothetical numbers. Okay, so they are not representing anything actual physical taking place over there. They are hypothetical numbers that we have assigned to the elements. And the second thing is, oxidation numbers exist because it gives us important, like two bits of important information. Okay, so one, it tells us whether an element, like where the electron shift is towards, like it tells us whether the electron cloud is shifted towards the element or away from the element. Like in HCl, H having oxidation number of +1 tells us that H is the less electronegative element here and electron density is shifted away from hydrogen. Okay, and second bit of information is it tells us the number of electrons that have been like that the particular atom has um, not exactly lost or gained, but that has shifted towards or away from it. So the number 1 here represents that, oh, so hydrogen originally has 1 electron. Its 1 electron is shifting away from it. And chlorine having an oxidation state of -1 tells us that, okay, chlorine originally, hello, are you guys able to hear me?
Yes, ma'am, now you're
Miss,
audible.
we can hear you at certain times, and then at certain times there's just a gap of time. Nobody's talking or anything.
Okay. Is that the case with everybody?
Yes, ma'am.
Oh,
But it happens
Yes,
for
ma'am.
like a few seconds and then
Yeah,
it's back.
it
yeah.
happens for a few seconds and then it comes back.
Okay. All right. Let me do one thing. Just give me 2 minutes. I'll check if there is a different place. One moment. Let me know if it still persists, okay? Yeah, so oxidation number. So in HCl, H having a +1 oxidation number just means that the plus indicates that the electrons are shifted away from H, and the 1 indicates that um, this the 1 electron that hydrogen has is shifting away from H. So the number indicates how many electrons is it, so to speak, say losing, because it's not losing completely, just indicating that the electrons are shifting away from it. And the sign indicates whether it's like losing or gaining electrons. Okay. All right. So oxidation number denotes the oxidation state of an element in a compound, ascertained according to a set of rules. So yeah, because oxidation state depends on how the difference in electronegativities, like how the electrons are shifting, whether it's towards an atom, away from an atom. So it is obviously, it's not random. It is assigned, like it's assigned based on a set of rules. And these rules are basically on the basis that electron pair in a covalent bond belongs entirely to the more electronegative element. So the rules, like because we are outright giving it a whole positive charge, negative charge, it is, again, this is not actually what happens in a covalent compound. We're just assuming that the electron pair in the covalent bond is like shifting completely towards the more electronegative element. All right. So rules to determine oxidation number. So this is very, very important. So yeah, like you, like a lot of times you will need to figure out what is the oxidation number of a particular element in a particular compound. So later on, even in organic chemistry, to figure out whether oxidation is taking place, reduction is taking place, which is the more stable oxidation state that an element can have, like all of this, like oxidation number will keep coming up later on also a lot of times. Okay. So oxidation number of an atom in the elemental state is 0. So elemental state, so that involves molecules like Cl2, O2. So as long as it's in the elemental state, there is no loss or gain of electrons, so to speak, right? So oxidation state is 0. The oxidation number assigned is 0. In ions of only one kind of atoms, the oxidation number is equal to the charge. So if I've got Na plus, what is the oxidation number of this, of sodium ion?
1.
So always when you talk about oxidation state, you also need to mention the sign, the charge it has. So it'll be +1. So you need to always mention it as +1 or -1. That needs to be mentioned, okay? Similarly, if I've got an oxide ion, the oxidation state of oxide would be
-2.
-2. Yeah. Oxidation state of alkali metals is always taken as +1. Okay. Similarly, like apart from this, I would also say oxidation state of alkali metals and alkaline earth metals. So alkali metals is always taken as +1, alkaline earth metals is always taken as +2. So this is like default oxidation state. They cannot take any other oxidation state in any situation. Similarly, oxidation state of fluorine is taken as -1. Oxidation state of oxygen is always -2. The only exception is in peroxides and superoxides, or if it is bonded to fluorines. Okay, so this is kind of like decreasing order of priority in terms of the rules of assigning oxidation states. So if you have a compound like OF2, all right, so oxidation state elemental state में कोई भी नहीं है. So always if there are alkali metals, assign them +1 first. Alkali metals are not there. If there is fluorine, assign fluorine -1 first, because fluorine is the most electronegative element that you will find in the periodic table. So fluorine will always take -1. It will never ever show a positive oxidation state. So after that, then you can look at assigning all the other oxidation states. So यहाँ पे there is nothing except oxygen and fluorine. So fluorine gets -1. So what would be the oxidation state of oxygen based on this? So that, yeah, so Mitali got it. Yes. So that we'll be calculating based on the overall charge of the compound itself and everything else. Okay. So if fluorine is not there, or if it's some other compound, like let's say sulfate ion, SO4 2-. So oxidation state of oxygen is default -2, unless it is a peroxide or a superoxide. And that too, it is -1 in peroxide, superoxide, like -0.5 in superoxide, because oxygen is like bonded to itself. So there is no like, when an element is bonded to its own self, like basically if it's bonded to the same element, if there's an OO bond, for example, electrons are shared equally between these two because there's no electronegativity difference. So the only electron shift is occurring partly from this external bond and this external bond. So that's the reason in peroxides and superoxides, you've got like fractional oxidation states. And only when it is oxygen is directly bonded to fluorine, then it takes a positive oxidation state, because fluorine is more electronegative and it pulls the electrons away, like towards itself. Oxidation state of hydrogen is always +1, except in metal hydrides. So again, when you have metal hydrides, like let's say sodium hydride, alkali metals always take +1. So that by default gives -1 to hydrogen. Otherwise, all the other compounds take water, ammonia, organic compounds, oxidation state of hydrogen, you always take it as +1. The algebraic sum of all oxidation states in a compound is 0. And if it is an ion, then it is equal to charge on the ion. It is 0 in a compound because a compound is overall charge on a compound is 0. It is a neutral compound. So if it is not neutral, it means it's an ion. So then it would be equal to charge on the ion. So that means we have got OF2 here. Oxidation state of fluorine is -1. Overall should be 0. So basically, if we don't know what the oxidation state on oxygen is, take that to be X. there are 2 atoms of fluorine. So 2 into minus 1 is equal to 0. 0 because overall compound is neutral. So based on this, you can find out what is the uh, oxidation state on oxygen in OF2. So x minus 2 equal to 0, which means that x will be equal to plus 2. So oxidation state of oxygen in OF2 will be plus 2. Similarly, can you find out what is the oxidation state of sulfur in sulfate ion?
Can you repeat the question, please?
Yeah, what is the oxidation state of sulfur in sulfate ion?
+6.
Okay, so how did you calculate that, Sid?
So oxygen is -2, and there are 4 of them,
Yes.
so it becomes a -8. I mean, there's 2 minus charge, so it becomes.
Yeah. So we don't know what sulfur's oxidation state is. 4 oxygen, each having -2, so that's total of -8. Overall charge should be equal to -2 because it's sulfate ion. So once you solve this, you get x equal to +6. Okay, awesome. All right. So oxidation state of an element is represented in the formula using Roman numerals. So this you will not, like, usually you will come across only where you have variable oxidation states like D block elements. So iron can take both +2 as well as +3 oxidation states. So this is how both of them are represented. So you just put it as a Roman numeral here. Okay. All right. So, okay, let's practice some over here. All right, first one. So can you assign the oxidation state of phosphorus in this compound?
+5.
Okay, I need answers from all of you, huh? Like calculate it and send it. You can send it over chat or you can say it. Okay.
Yes, ma'am. +5 बोली.
All right. Ishita, Maya, Sriti, you guys got it?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Ma'am,
Plus
can we do
5.
like
Yes,
one or
ma'am.
two more?
Sorry, what?
Like we can do one or two more.
Yeah, definitely. Okay, next, sodium hydrogen sulfate or sodium bisulfate. Second one, oxidation state on sulfur here. Maya's always put sign to it. So whenever we're talking about
Minus
oxidation state, you have to mention whether it's plus or minus. Sid
plus,
got
oh,
it?
plus
Ishita,
6.
no. Yeah. Okay. So Ishita, you need to check your sign. So alkali metal, this will always take +1. Hydrogen also +1. Oxygen is -2 into 4. So 8, this comes up to -8 plus 2 is -6. But compound neutral hai na? So what should sulfur be so that overall is 0? So then it will be +6. Cool. Next, what is the oxidation state of boron in this? So this is sodium borohydride. Hydroborate, sorry. Yeah. Wow, good. Sid already has got it. So find out the oxidation state of boron. Maya's got it.
Ma'am, I have a doubt.
Yeah.
Ma'am, yesterday I did P block elements where it said boron cannot expand its maximum covalency is +4, right? If I'm not
Boron
wrong.
is P block, right?
Yeah,
One moment. Wait. Boron is atomic
+4.
number 5. So that's 2, comma 3.
Yeah.
Yeah. Okay.
So how is it like -5? Like, I don't know if I'm making sense. Am I?
Okay. Now, what exactly did it say? Like, what is your doubt?
Just a second.
Hmm.
It's like boron is an exception, right? It cannot expand its covalency and its maximum oxidation state, I think, is +4.
Is it?
Yeah, ma'am, I'll check. I'm
Yeah.
not sure. Just a second. Yeah, ma'am, due to the absence of d orbital, the maximum number of covalency in boron is 4. But wait, covalence is different than oxidation state, right?
Hmm. So, again, 1 second.
Yeah.
Yeah. So, NaBH4 is actually sodium borohydride.
Okay.
So, in NaBH4, again, because it is a hydride, the oxidation state of hydrogen should be taken as -1.
Okay. Oh, because it's a hydride. Okay, got
Yeah.
it. Sorry. I mean, I don't know.
Okay. So, Sid and Myers, just take note of it. So, based on this, yeah, if you calculate the oxidation number on boron will come out to be +3. That's the reason I wanted you guys to do this right now,
Why is the hydrogen of -1 charge?
because it's hydride. Yeah, it's a hydride compound. So similarly, same is the case with lithium aluminium hydride, LiAlH4. So it's a hydride. So in this case also, lithium alkali metal will be +1. Hydrogen will take -1 in this because it's a hydride.
Okay, so if hydrogen is paired with another cation, then it becomes it adapts a -1 charge.
Yeah. So another way to like figure this out is the convention is to always place cations first and anions next. Okay, so that's like the order even when you're writing any compound. So if you look at how compounds are represented, it's always represented in increasing order of electronegativity. So least electronegative to most electronegative in any case, like in any compound that you see. So based on that, also you can say because hydrogen is in the end, it's a hydride compound. All right. Dhriti, Ansh, I have not received answers from you guys. Okay, next. What are the compound? ठीक है, H2S2O7, oleum. So इसमें what is the oxidation number for sulfur?
Oxidation number.
Mitali has sent an answer. Dhriti also sent it. Let me check. Yes, both of you are right. Come on. Ishita, Ansh Gupta, Mayas. Sid has sent it. Correct. Ishita, Ansh, and Mayas, are you guys solving it?
Yes, ma'am.
Send it then. क्या हुआ? Shouldn't take this much time. So where you stuck, Ishita? Okay, got it. Good. +6. So hydrogen is +2 because 1 into 2. Sulfur, we don't know. So 2x. And oxygen is 7 into 2. So -14. So overall 2x equal to +12 आएगा. So x will be equal to +6. ठीक है. ठीक है. So you guys got the hang of figuring out oxidation states, right? Or do you want to practice some more?
Yes, ma'am, got it.
Cool. Now, some compounds will have fractional oxidation states. So this is evident mostly in, as we saw, superoxides के case में, and even some other organic compounds, all that. Like an example is given here, C3O2 में. So if at all you get the oxidation number as fractional, it does not mean that half an electron is transferred or shared. It's like oxidation state basically signifies the average oxidation states of all the atoms. Now the individual atoms can have, like, because this has 2 electrons being pulled away from it, it shows +2 with respect to oxygen, but with respect to carbon it is 0. And you can see that the central carbon here is completely 0 because it's bonded to 2 other carbons. Like there's no pull of electrons or push of electrons here. And same with the third carbon, it's +2 with respect to oxygen, but 0 with respect to the other carbon it's bonded to. So overall, 3 carbons, this is showing +2, this is showing +2, this is showing 0. So the average comes out to be +2. plus 2 divided by 3 would be plus 4 by 3. So even when you calculate it by your conventional method, 3x plus minus 4 equal to 0, because it's a neutral compound, you get x equal to plus 4 by 3. So basically, the oxidation state that you calculate based on the previous this thing is the average oxidation state. So it kind of gives you a hint into the structure also. So if at all you get fractional oxidation state, it means that, oh yeah, okay, this particular atom is bonded to another atom of the same element. So isliye you're getting the fraction. Okay, other cases, if you check oxidation number of bromine and Br308, you would get fractional. And oxidation number of metals in mixed oxides like Fe3O4 is a mixture of FeO and Fe2O3, like both iron plus 2 and plus 3 oxides ka mixture hai. So if you calculate it based on like in the conventional method, you get fractional because it's a mixture of plus 3 and plus 2 oxidation states. That way. Okay. So redox in terms of oxidation state. So once you know the concept of oxidation number, you can easily figure out whether oxidation is taking place or reduction is taking place. So if there is an increase in the oxidation number, so oxidation number increase matlab plus value is increasing, matlab it is losing more electrons. So that indicates oxidation is taking place. And if there is a decrease in oxidation number, so oxidation number is reducing, so you say reduction is taking place. So oxidizing agent is the reagent which can increase the oxidation number of an element. So they are also called oxidants. So once you figure out oxidation and reduction, right? So you have A plus B gives C plus D. If you know that A is getting oxidized to C, then B will be the oxidizing agent. So the element other than whatever is causing this thing will be the oxidizing agent. So similarly with reducing agent. If you know that A is getting reduced to C, then B is the reducing agent. That way. Okay. Good oxidizing agents, good reducing agents. A substance is a good oxidizing agent when any of its elements is present in the highest oxidation state. So an example is potassium permanganate. So potassium permanganate is KMnO4. Can you calculate the oxidation state of manganese in this compound? Mitali, check your calculation. It is not plus 6. KMnO4. K ka oxidation state will be Sid got it, yes. That's a little typo there, but yeah. Now Mitali got it. Maya's got it. Good stuff. Yes. Okay. So K is plus 1. This is 4 into minus 2 is minus 8. So manganese ka oxidation state is plus 7, which means that it's losing like 7 electrons. So do you think like can this increase beyond plus 7? Is it possible to have oxidation states of plus 8, plus 9, plus 10?
No.
No, right? Like maximum octet तक जा सकता है, like the whole intent like valence shell में 8 से ज़्यादा नहीं हो सकता है, right? So which is why there is no way for manganese, like if this has to change its oxidation state, it needs to go below plus 7. Like the only change possible for manganese in potassium permanganate is reduction, which is why if it itself is undergoing reduction, it means that it can oxidize something else, which is why potassium permanganate is one of like a universal oxidizing agent. It is like that's if you want oxidizing agent, it is a go-to in laboratories. Similarly, same is the case with potassium dichromate, K2Cr2O7. So usually if you find that some element is in +7, +6 oxidation states, they are very good oxidizing agents. Okay. And it is also a good good oxidizing agent. Any of the elements is present in the highest oxidation state. And otherwise, you can look if any element is in the intermediate oxidation state. So for example, peroxide, oxygen ka oxidation state in peroxide H2O2 is -1. Now oxygen can go either -2, or it can get turned into a superoxide and take like plus minus half. So whenever it's in the intermediate oxidation state also, it's a very good oxidizing agent because it itself can get reduced. And a substance is a good reducing agent when any of its element is present in the lowest oxidation state. So if it is in the lowest oxidation state, there is no other way than to increase its oxidation state if it has to change.
Ma'am,
Yeah, Mayas?
ma'am, when you say the element is in intermediate oxidating state, what does that mean? Like 4, 5
Oxidation state.
plus 4
मतलब
plus 5.
नहीं, intermediate मतलब from, so every element has a list of possible oxidation states, like except for alkali metals and fluorine, all the other elements like oxygen, when
We can
it's
talk
in,
about the example only, na hydrogen
yeah,
peroxide.
so hydrogen peroxide में, okay, keep this aside. So oxygen can exist as an oxide ion when its oxidation state is -2, or it exists as peroxide ion. What is the oxidation state of oxygen when it's peroxide?
-1,
-1. And when it is superoxide,
-1/2.
this is -1/2, right? So oxygen can take values, and of course, like when it is bonded to fluorine, it takes like +2. But yeah, so oxygen can take values ranging from -2 to +2. Like if it is in OF2, then it only takes +2. But yeah, otherwise it is ranging from -2 to +2. So intermediate oxidation state मतलब lowest और highest के बीच में जो है. So -1 is intermediate because it is in between the lowest and the highest oxidation states. So that's what intermediate means. Like for example, manganese can take values, like elemental manganese is 0. It can take values of +1, +3, +5, +7. When it is in the highest oxidation state, it's a good oxidizing agent. Intermediate matlab between the highest and lowest. When it's at like +1, +3, +5, it can go both ways. And when it's at the lowest oxidation state, it's a very good reducing agent because it can only increase its oxidation state. It can only lose electrons. So it becomes a good reducing agent. Okay, so intermediate is basically when it is between the lowest and highest. So yeah, peroxide में oxygen is in +1 and it can go to +2, -1, and it can go to -2, tendency to go to -2, which is why it's a good oxidizing agent. Okay. Okay. So determine if the following reactions are redox reactions or not. And for each redox reaction, write the oxidation reduction half reactions. Okay. So the first one, is this a redox reaction? So you can't look at it in terms of elements because addition of oxygen says it is oxidation, but addition of hydrogen is also taking place. So how do you decide if it is reduction or oxidation?
Electrons.
Electrons. Electron transfer.
So, ma'am, here we'll write oxidation states above the thing, right? To check.
Yes, correct.
Okay.
I don't
Check
think
oxidation state of. So what is the oxidation of sulfur in SO2?
so. For in that case, it's +4.
+4. Oxygen will be -2.
-2
यहाँ पे
+1
+1 -2.
-2.
Here, what is the oxidation state of hydrogen? Will be the same. Oxygen will be.
+1, oxygen will be mine.
तो
Will be
सल्फर
Plus
का क्या हो रहा है?
+6.
+6
Okay,
है
wait.
क्या?
Wait.
sulfur will be +4.
+4. Yeah. So was there any exchange of electrons taking place here?
No, ma'am.
So is this a redox reaction?
No.
This is
It's
not it.
not even a half reaction.
I mean, so like if you do not have oxidation or reduction, then there is no question of oxidation half reaction or reduction half reaction. So yeah, so this is not redox. Okay, what about this one? Na plus Cl minus Ag plus NO3 minus. In solution, because AgCl is insoluble, it combines to form a precipitate. In solution, you have Na plus and nitrate ions. Is this a redox reaction?
Not a redox reaction.
No, but it could be, right? Because it's Cl minus is going from Cl. No, but it's still okay. Sorry, the oxidation state remains the same.
Yeah. So this is not redox. This one,
It is a redox reaction.
okay. So how did you figure that it's a redox reaction?
Ion.
That was a obvious giveaway. So ion, here it is +2, here it is +3, and तो अगर एक this has increased oxidation state, which means that is this reduction or oxidation?
It's oxidation.
Oxidation. So if this is oxidation, where has reduction taken place?
Mn?
Cool. तो यहाँ पे Mn oxidation state क्या है?
+7.
+7.
And product side में how much has it become?
+10.
+2.
Sorry, yeah.
Yeah, sulfate ion है ना इधर.
Yeah,
So,
my bad.
yeah. Cool. So +7 to +2 reduction taken place, +2 to +3 oxidation has taken place. So how do you write the half reaction here?
In the ionic form.
Yes.
So like K +7 plus.
K +7? No.
Oh, no, sorry. Mn my bad. Mn +7, and
So this
you
is
add.
a permanganate ion, right? Now Mn +7 does not exist in reality. It's the oxidation state we've given here. So if you, yeah, so you have to write MnO4 minus.
Fe2 plus.
Yeah, this becomes Mn2 plus.
Yeah.
And oxidation, So Fe2 plus becomes Fe3 plus.
You have to write a plus one electron, or
Yeah, ma'am. Do we need to write that? I mean, I think in school we did write that electrons are added because it's half reactions.
Yeah. Yeah, I mean, to balance it out, might have to write it.
Yeah, yeah. Plus 5 electrons, right?
Yeah.
And minus 1 electron.
Yes.
Oh, ma'am, doubt. Do you write minus 1 electron on Fe3 plus के side or Fe2 plus के side?
So you can write plus 1 electron on Fe3 plus.
Okay.
Either of it, I mean, both of them represent the same thing. So
Yeah.
yeah, that way. Cool. Then the last one.
Yes, ma'am, it's a redox reaction.
Okay, what's getting oxidized? What's getting reduced?
So Br goes from minus 1 to 0 and Cl goes from 0 to minus 1.
So which is oxidation? Which is reduction?
Br is oxidation
Yes.
and chlorine is reduction.
Yes. Cool. Cool. Any doubts here? Ansh, Priti, Ishita, Mahesh?
How do we find oxidation state for HBr? I'm a bit confused.
HBr ना तो दो ही elements है HBr. Which is more electronegative between hydrogen and bromine?
Bromine.
हाँ. H usually takes oxidation state of
+1.
+1. So bromine will be -1. Same as HCl. H takes +1, Cl takes -1.
Okay.
Okay. Any other doubts?
Roman, how are we writing directly the eighth question?
Eighth में
Because in school we had a very long process of writing, because first I would write KMnO4 is converting to MnSO4, and then
No,
we
you're
will
talking about like balancing the equations and all. This is just identifying ki what is oxidation, what is reduction. So
and why do we add 5 electrons on left hand side?
just for balancing, because manganese was at +7, इधर 2 +2 हो गया. So this is possible only when 5 electrons are added to it.
Okay, okay. We are balancing the charge.
Yeah. So balancing
Is
भी
there any
आएगा.
rule for, like, when we have oxidation, we add electrons on the right side, and when we have reduction, we add electrons on the left side?
ऐसा rule तो नहीं है, because whether you put minus electrons on LHS or plus electrons on RHS, they stand for the same thing.
Okay.
Yeah. Fine. So again, like when you have the method for balancing, right, you have a set of rules, right? So we'll discuss that when we are like talking about like the balancing redox reactions. Okay. Now coming to types of redox reactions. So basically, again, you have types of reactions based on energy changes, exothermic, endothermic. That way, these are types of reactions based on what is happening to the elements. So oxidation state of the elements. Okay. So you've got combination reaction, decomposition reaction, displacement reaction, disproportionation reaction. Will double displacement reaction come under redox?
It should, right?
Why?
I mean, okay, can you give me an example? I can't think of one.
double displacement, double displacement sulfate के साथ, let's say Na2SO4 plus, let's say, BaCl2 gives NaCl plus BaSO4.
Okay, no, it shouldn't come because the oxidation state remains the same throughout the reaction.
Yeah. So usually what happens in double displacement is that just the ions get exchanged, and the only reason this reaction even takes place is because one of the products is insoluble. It precipitates out. So basically, yeah, the overall effect is that the ions are exchanged between the compounds. So their oxidation state as such does not change. Okay. All right. So these three reactions you guys are familiar with. If you remember, combination, decomposition, and displacement. It's only disproportionation reaction that's new. So combination reaction, as we all know, two reactants combine to form a single product. So redox happens when at least one reactant is in the elemental state. If you don't have any elements in the elemental state, then it doesn't come under a redox reaction. Okay. So at least one reactant, if it's in the elemental state, it forms a redox reaction. So can you guys think of an example of a combination reaction which is not a redox reaction? Anyone?
Ma'am, which is a redox reaction, which is not a redox reaction?
So combination may, when you have at least one reactant in the elemental state, it's a redox reaction.
Okay.
So I'm asking, can you think of any situation, any combination reaction, which is not a redox reaction?
Can it be hydrations?
Hydration, yeah, that's a good example. But again, it's
H2 plus Cl2 will give me 2 HCl.
Mitali.
I just messed up.
did
Sorry.
you identify what you did here?
Oh, it's 0, 0 minus 1. Sorry.
Mm. Do you know the formation of calcium carbonate, the reaction for the formation of calcium carbonate?
Calcium oxide plus CO2.
Is this a redox reaction? One moment.
No, it's not.
So this is plus 2. Here also it's plus 2. Oxygen is minus 2 throughout. And carbon is at plus 4 throughout. So yeah, so when you don't have like anything in the elemental state, it is not a redox reaction. But
So, ma'am,
yeah.
yeah, you're about to finish it. Yeah.
But when you have at least one reactant, in this case, both reactants are in the elemental state, so this is a redox reaction. Because when they're combining to form a compound, its oxidation state is obviously going to change. It is definitely not going to remain at 0. Elemental may, it is 0. So for sure, if at least one of the reactants is in the elemental state, you can say that it's a redox. When you don't have it, then you'll have to like check the individual compounds itself. It is not a hard and fast rule that if it is not in the elemental state, then it's not a redox reaction, but you'll have to take a look. But if you see that at least one reactant is in the elemental state, you can blindly say that, yeah, it's a redox reaction. Okay. Yeah, Mitali, you were going to ask?
Yeah, I was asking the same thing, and if like finished your explanation, I got it.
Cool. Next, decomposition reaction. It is the opposite of combination reactions. So single reactant splits into two or more products. Again, just like combination, all decomposition reactions are not redox reactions. If at least one of them is in the elemental state, again, for sure, blindly you can say that it's a redox reaction. Otherwise, you will have to look at the oxidation states to figure it out. So again, decomposition of calcium carbonate. Displacement reaction. So one element displaces another less reactive element from its compound. Okay, now based on what you see, what is the definition and pattern of displacement reactions, can I make a statement saying all displacement reactions are definitely redox reactions?
Yeah, you can.
Pakka?
Pretty much, yes.
Okay.
Yeah, ma'am.
Yeah, because one of the elements is always in the
Elemental state.
yeah, which is the one that is doing the displacing. So yeah, that ends up being redox reactions. So like metal displacement reactions, you guys are familiar with. A more reactive metal displaces a lesser reactive metal from its compound. Non-metal displacement reactions, examples are here. So wherever hydrogen is displaced, right, in reactions with water, reactions with acids, again, it's hydrogen being displaced. So that will come under an example of a non-metal displacement reaction. Okay.
Ma'am, it also follows the same law, right? At least in the case of halogens, where a more reactive element displaces a less reactive element.
Yes, always, that's like a universal law. A more reactive element always displaces a lesser reactive element, whether it is metal or non-metal. That is always the case.
Okay, ma'am.
Yeah. The reason is that, again, a more reactive element will want to be in its like compound state, like a lesser reactive element, it is inert. Less reactive matlab it is more inert. It will not mind being in its elemental state, so it can easily get converted to its elemental state. So be it metals or non-metals, that is the case.
Yes, ma'am, got it.
Yeah. Now coming to disproportionation reaction. Disproportionation reactions, like if you see that the same element undergoes both oxidation and reduction. Okay. So then that kind of a reaction is called a disproportionation reaction. So condition for disproportionation reaction is that in the reactants, one element in the reactant should be like, it should be able to exist in multiple oxidation states. So some of the elements, like if you have hydrogen, you have fluorine, you have alkali metals. Okay, not hydrogen, but yeah, fluorine and alkali metals cannot exist in multiple oxidation states. Alkali metals always take +1, fluorine always takes -1. So those elements cannot undergo disproportionation at all. So only the elements that can exist in multiple oxidation states can undergo disproportionation. And another thing, for it to undergo both oxidation and reduction, it means that the oxidation state should be able to increase also and decrease also. So in the reactant, it should exist in the intermediate oxidation state. Okay. So as it's given here in the example, hydrogen peroxide peroxide में oxidation state of oxygen is -1. When it decomposes, so it oxidizes to elemental oxygen and reduces to water. So this reduction has taken place, and over here oxidation has taken place. So same element oxygen has undergone both oxidation and reduction, which is why it's a disproportionation reaction. So you can see that -1 is in between 0 and -2. So it's in one of the intermediate oxidation states. And also oxygen is able to exist in all three oxidation states, which is why this reaction is possible. That's all there is. So, and yeah, of course, like you've got other examples. Phosphorus undergoing disproportionation in alkaline medium, sulfur going disproportionation, and chlorine undergoing disproportionation. So these are all reactions that you will come across when you're studying about phosphorus, sulfur, and chlorine again. So these are reactions with a strong base like NaOH. NaOH solution may, these are the reactions that they undergo. So again, as I mentioned, all halogens except for fluorine show disproportionation reaction because fluorine can only show -1.
Ma'am, so wait, so sodium, so like you said that fluorine cannot show disproportionate reactions because it does not, it only exists in one oxidation state, right?
Yeah.
So what about like metals,
Metals also,
like alkali and alkaline earth metals?
they
They
don't
will also
undergo.
not show
They will
disproportionate
not show.
reactions.
Yeah.
Okay.
So this particular reaction that you see here, so fluorine in the presence of a strong base becomes fluoride, you get OF2 and water. So all halogens undergo this type of reaction, like reaction of this format. But fluorine, like the reaction that fluorine undergoes is not disproportionation, but all the other halogens that undergo this reaction will come under disproportionation reaction. So an example is given here. So chlorine in the presence of oxygen becomes chloride and chlorate and water. So fluorine also had undergone similar reaction, but yeah, so reactions of this format for all the other halogens come under disproportionation except for fluorine. Okay. Now coming to balancing redox reactions, you have two ways of balancing redox reaction. One is the oxidation number method and one is the half reaction method. Okay. So oxidation number method, step one, first you write the skeletal equation. Like I'll do it with an example also with you guys, so don't worry about it. So step one, write the skeletal equation. So you need to write the correct formula of the reactants and the products. Step two, assign the oxidation states to each element. Then step three, calculate the increase or decrease in oxidation state per atom and the molecule and balance it such that the increase in oxidation state should be equal to decrease in oxidation state. Then step 4, balance the ionic charge by adding H plus or OH minus in the appropriate side. So this you will get information from your question statement itself. So if the question states that, oh, it is an acidic medium, then you use H plus. So if you need to increase charge on LHS, add more H plus on LHS. If you need to decrease the charge on this side, then you add more H plus on the RHS that way. And if the question states that it's alkaline medium, use OH minus. And step 5, count the number of hydrogen atoms on either side and add suitable number of water molecules to balance H on both sides. So you use H plus OH minus only to balance the charge, and to balance the number of hydrogen atoms, you do that by adding water molecules. Okay, so don't add H plus by, like, to balance hydrogen atoms. If you need to balance hydrogen atoms, do that by adding water molecules. All right. An example here, give the balanced chemical equation for the reaction in which permanganate ion reacts with sulfur dioxide gas in acidic medium to produce Mn2 plus and hydrogen sulfate ion. I'll do it on the whiteboard. Okay, so the first step is to write the skeletal equation. So permanganate ion reacts with sulfur dioxide gas. So what should my reactants be? Permanganate ion reacts with sulfur dioxide.
MnO4 minus
Huh.
plus. Ma'am, MnO4 minus uska the it should be aqueous, right? Because it's a
Yeah, so if you're mentioning the state, of course, like all of these
state.
take place in this
Sorry.
thing. Yes.
Okay.
So permanganate ion reacts with sulfur dioxide gas plus sulfur dioxide.
SO2
Hmm.
gas.
So it says in the acidic medium. So should I add H plus over here?
Above the arrow?
No, like in the reactants.
No, ma'am, we do it in the end, no.
Yes, good. So the medium is mentioned just so when you balance the charges, you know whether to add H plus or OH minus. That way. Acidic medium to produce Mn2 plus and hydrogen sulfate ion. That's pretty straightforward. Mn2 plus and hydrogen sulfate ion. So what is hydrogen sulfate?
H2S.
Mm-hmm. Hydrogen sulfate ion. So it's literally
HSO4.
HSO4 minus आयन है ये SO4 2 माइनस को एक H प्लस ऐड हो गया that way. ठीक है. So we've got our skeletal equation here. So step 2, assign oxidation states to each element. Okay, MnO4 minus में oxidation state of Mn
7.
always don't forget the sign
Plus
minus
7.
plus 7. Sulfur SO2 में
Plus
sulfur
4.
Plus 4.
plus 4. Mn2 plus
2 plus.
Plus
plus
2
Okay.
only.
HSO4 minus
Six plus 6.
nice plus 6. Okay, assign किया. Now calculate the increase or decrease in oxidation state per atom and the molecule. and balance it such that increase in oxidation state should be equal to decrease in oxidation state.
So here is where we write half reactions, right?
You don't need to write half reactions in this method. Like
Oh,
that's, yeah. So here you just directly add the numbers to balance this out.
okay, ma'am.
Ma'am, I'm not getting. Well,
Yeah.
I know the method we were taught in school, but do we do the
Okay.
same?
Yeah, same thing only.
So I divide this into oxidation and reduction, and I write the
Oh,
oxidation.
that's a different method. So that's like the half reaction method. You divide it into oxidation half reaction, reduction half reaction.
Ma'am told us that the first one is not coming in exam.
Oh, you don't have to. Acha. Okay.
We have two methods now.
Yeah, this is the first method. This is the oxidation number method.
Yeah, she said
Ion
oxidation.
electron method is going to come in exam.
Only
Yeah,
ion electron method is
I was
coming.
looking for the name.
Okay. So,
Ma'am, but
like,
even for ion electron, the first steps are the same only, no?
yeah, you divide it into oxidation. I mean,
Yeah.
to recognize whether it's oxidation half or reduction half, you calculate, like, you check this and then you divide it. Okay, let's
Okay.
let's go with that method then.
Yeah, ma'am.
We'll save time. Okay. Uh, all right. So, which is the oxidation half reaction and the reduction half?
Mn plus 7 to Mn plus 2 is oxidation,
Mm-hmm.
and sulfur plus 4 to sulfur plus 6 is reduction.
Okay, so let's split it and write it here. So MnO4 minus 2 Mn2 plus, this is reduction, and SO4, sorry, SO2 to HSO4 minus, this is oxidation half. Okay, and just keep in mind this was an acid in acidic medium. Cool. Once we have separated it out, balance all the elements except hydrogen and oxygen in the half reactions. Elements other than hydrogen, oxygen, manganese is balanced here, sulfur is balanced here, right? So that's done.
Ma'am, could you add electrons? Because we were said that electrons are very necessary.
Yeah,
Even you're doing this.
cool. So MnO4, this is oxidation state plus 7 to plus 2, and this is plus 4 to plus 6. So plus 7 to plus 2, so MnO4 minus plus 5 electrons gives Mn2 plus, and SO2 gives HSO4 minus plus 2 electrons. Okay, so this comes into picture when we add the oxidation half and the reduction half, because the number of electrons lost should be equal to number of electrons gained. So that we will have to do that anyway. Actually,
But
this,
is this the first step?
no, you should not do this in the first step, because this comes right in the end, because even from the medium you have ions getting added, right?
We have to add water and hydrogen now first.
Yeah. So first balance out all the elements first, and then to balance the charges, then you add the electrons there.
Yeah, for me, ma'am, the third step is add electrons. That's why. Like,
Oh,
I don't know what we did in my class, but that's what the third step is.
okay. Let's show you the whole process first.
Yeah.
An overview here. Yeah. So first, convert all compounds of unbalanced equation into constituent ions. Um, So basically what this means is that if you have KMnO4, then convert them into MnO4 minus. So like this is required so that you can separate out the oxidation half and the reduction half. Then once you have the half reactions, you balance all the elements except H and O, law of conservation of mass, number of atoms on LHS equal to number of atoms on RHS. The reason why you leave out hydrogen and oxygen is because you do have hydrogen oxygen from the medium, like from the acid or the base or water. So yeah, balance everything except H and O. Then balance hydrogen and oxygen atoms by adding water or H plus or OH minus. Now this depends on your medium. So if you're doing it in acidic medium, you balance out the oxygens by adding water molecules and hydrogens by adding H plus. And if the reaction is in basic medium, then you add an extra OH for every H plus that is added. So basically, if you find that there is, you need to add H plus in a particular like either LHS or RHS, then it always comes in combination. Like you need to add an extra OH minus for every H plus. If you need to balance out oxygen, then it's pretty straightforward. Like OH minus, say you get the oxygen. But yeah, if in case you see that you need to add H plus, then you need to add an extra OH minus for every H plus added. Now, once all your atoms are balanced, all atoms are balanced, number of atoms on LHS is equal to number of atoms on RHS, then you balance the charges by adding the suitable number of electrons. Then multiply the half reactions by a suitable number to make number of electrons equal on LHS and RHS. So this is important because the total number of electrons lost in oxidation should be equal to total number of oxidation electrons gained in reduction. Okay, so that's why you need to make the total number of electrons equal for oxidation and reduction. Then you add the half reactions to cancel out the electrons on each side and verify that the number of atoms and charges are equal on LHS and RHS. So coming back to our equation here, we have separated them into oxidation half and reduction half. We have balanced all the elements. We just had manganese and sulfur. Now let's balance the OH, H and O atoms by adding water, H plus or OH minus. Now our medium was acidic. So in order to balance out hydrogen, you can just add H plus. In order to balance out oxygen, add water. Okay, let's do it. All right, reduction half में we have 4 atoms of oxygen here. So how will you balance out oxygen?
Two H2O. He'll add two H2O on the.
LHS or RHS?
So we are doing MnO4 first, the right hand side.
Right hand side, yeah. Gives Mn2 plus 2H2O. 2H2O, 4H2O. Oxygen तो balance नहीं हुआ ना?
4
Oh, actually, I told 2 for the first, the oxidation part. That's
अच्छा,
4
okay. 4H2O. Abhi, यहाँ पे we introduced hydrogen, which means that how do you balance out the hydrogen now?
H plus.
On LHS or RHS?
LHS.
Huh. How many H plus do you have to add?
8.
Okay. So now all the things are balanced here. Elements are all balanced. What about, okay, later. So we'll look at oxidation half also. Now, how do we balance out hydrogen and oxygen here? Sulfur is balanced, so shouldn't disturb this. There are 2 oxygens here and 4 oxygens here. So Sid, Mitali, how do you balance out the oxygen here?
Just a second, ma'am. 2H2O.
Plus 2H2O
Yeah.
gives HSO4 minus. Okay, अभी oxygen balance हो गया. Are hydrogens balanced now?
No, ma'am. So I think on the left hand side you'll add 4H plus ions.
Left hand side?
Right hand side. Sorry.
How many are you going to add?
4.
Are you sure?
3. Sorry.
Focus. VH plus. Okay. So abhi all the atoms are balanced now. Hydrogen, oxygen, sulfur, manganese, they're all balanced. So now once the elements are balanced, now we need to balance the charges. Reduction half mein, what is the total charge on LHS?
How do you calculate total charge?
So manganese, permanganate ion say MnO4 minus say you have -1 charge here plus
And there plus 8.
8 here. So total we have is +7.
Plus 7.
On this side we have 1 Mn2 plus giving +2 charge.
That's it.
Yeah, so we have +7 on LHS, +2 on RHS. So how will you balance this out?
5 electron on LHS.
Yeah.
So MnO4 minus plus 8H plus 5 electrons gives Mn2 plus 4H2O. Okay, now on oxidation half, SO2 is 0, water is 0. तो यहाँ पे total charge कितना है?
Ma'am, the total charge should be +2.
+2, yes. So how will you balance out?
Remove 2 electrons from the right hand side.
Yeah. Remove 2 electrons. Add 2 electrons. Yeah.
Sorry, ma'am. Sorry.
SO2 plus 2H2O gives HSO4 minus plus 3H plus 2 electrons. Okay. Now everything is balanced on reduction half and oxidation half. Now we need to combine both of them. So now comes the step where you have to multiply either of this such that, so number of electrons on LHS should be equal to the number of electrons on RHS. So how will you manipulate it?
Ma'am, could you repeat that again?
So now when we are combining this, the electron part of it should get cancelled. So we have electrons on LHS here, electrons on RHS here. So we need to manipulate these two equations such that number of electrons on LHS should be equal to number of electrons on RHS.
You do the simultaneous equation thing where you multiply both the equations by a factor.
Correct. So what do you have to do in this case?
For oxidation, it will be into 5, and for reduction, it should be into 2.
Yes. So this makes it, so if I do it into 2 here, I get 2 MnO4 minus plus 16H plus 10 electrons gives 2 Mn2 plus 8 H2O. In this case, I get, so this one is 5. The factor is 5. 5 SO2 plus 5 into 2, 10 H2O gives 5 HSO4 minus plus 15 H plus 10 electrons. Now add both reduction half and the oxidation half to get your original reaction back. So 2 MnO4 minus plus 16H plus 10 electrons. Now LHS from this side, 5 H2O and 10 H2O. Sorry, 5 SO2 plus 10 H2O gives 2 Mn2 plus 8 H2O. Okay, 5 HSO4 minus 15 H plus and 10 electrons. Now you can cancel out like the common things from LHS and RHS, starting with your electrons. So 10 electrons gets cancelled. And the common elements that you have, right? Your H plus and H2O, you can solve it over here. So just fine tuning it, you get 2 MnO4 minus plus, so 16H plus on this side, 15H plus on this side, that will be left with 1H plus on this side. And what about for H2O? We've got 10 H2O on this side, 8 H2O on this side. So we'll be left with 2 H2O over here. Okay, so this is the final equation. This is the balanced redox reaction. Okay. So how's it going, you guys? Where are you?
Ma'am, could you give us one for like right now before we leave
Yeah,
class?
of course, definitely.
Yeah, so we can try it because this is some long
I'll just give a summary so that it's easy for you guys to make sense of. So you divide it into reduction half and oxidation half, because like dealing with smaller quantities always makes things easier, and it also you can make sense of it, because at the end loss of electrons is equal to gain of electrons. So now the first steps are always balancing the elements out. So here at this step you balance out all elements except hydrogen and oxygen, and after that you balance out the hydrogen and oxygen itself by adding in H plus OH minus water depending on the medium. Okay, so don't worry about charges at all. First step is balance the elements. So balance elements other than H and O, and after that balance H and O by manipulating, like adding, subtracting water, H plus, OH minus. Once your elements are balanced, then you look at balancing charges. So your balancing charges should only happen through electrons. So wherever you have excess charge, add those many number of electrons there. So first balance the elements, then balance the charge by adding electrons on LHS or RHS. And then when you're adding both the half reactions, manipulate it so that loss of electrons should be equal to gain of electrons. So number of electrons on LHS should be equal to number of electrons on RHS. So these are your three main milestones. So one, balance elements. This all except H and O first, then balance hydrogen and oxygen. This depends on your medium, H by adding H plus, OH minus, H2O in the right quantities. Once your elements are balanced, then you balance out your charge. So this happens by adding your electrons on the correct side. Then manipulate your equations and add both the half reactions, oxidation and reduction half. Okay, so just remember these three steps and you'll be able to follow. Okay, so we'll do another one. All right, write balanced chemical equation for dichlorine heptaoxide in gaseous state combines with aqueous solution of hydrogen peroxide in acidic medium to give chlorite ion and oxygen gas.
Ma'am, I actually have another class right now. Can I do this for homework and can I leave?
Yeah, you can do that. So you can
Okay.
just note down the skeletal equation so you know what
What is heptaoxide?
hepta. Figure it out. What do you
7.
mean by 7? So dichlorine heptaoxide would be
C2O7.
C2O7. Cl2O7.
yeah.
Cl2O7. Ma'am, my brain has stopped functioning, ma'am.
Yeah, you probably need like after the class, take like a 15-minute break or a half an hour break, recharge.
Yes, ma'am.
Ma'am, thank you.
All right, I said.
Bye-bye.
Chlorite ion. So chlorite formula is
Cl2O7, but there'll be some sort of charge or gas.
Yeah.
Okay. Plus
Cl2O7
solution of hydrogen peroxide. So H2O2 will give us chlorate. Oh, chlorite. So
chlorite is
C2O
ClO minus. ClO2 minus.
Minus and plus O2.
Yeah.
Okay.
Wait a minute. Sorry. Chlorite hai na?
Yeah, ma'am.
Chlorite is ClO minus. 2 nahi hoga.
I mean, this question of किसका oxidation number लिखें? Chlorine.
Chlorine is 1, yes.
For Cl2 in Cl2O7, chlorine we can write for chlorine.
Yeah. Okay. So सबका ही लिख लो. Like because oxygen gas is evolved, obviously oxygen का भी कुछ तो change हो रहा है इधर. So that'll help you figure out. Yeah. So once you write the oxidation states, right, that will help you identify which is oxidation, which is reduction easily. So जहाँ भी oxidation state reduce हो रहा है, That's reduction. And जहाँ पे increase हो रहा है, that's oxidation.
Ma'am, what is chlorine's oxidation state?
So that you'll have to figure out based on this thing, right? So Cl2O7 में तो it would be
Because it won't be -1, right?
no, it won't.
Yeah. Because it has variable oxidation states, right?
Yes.
It will be 7 plus 7.
Plus 7, yeah. Plus, okay.
Asha, just one correction, you guys. So I was right the first time around. So chlorite ion is ClO2 minus.
Okay, ma'am. Ma'am, but here now, how do we? Okay, so I found that chlorine undergoes reduction, okay, because it gains electrons and lowers its oxidation state. But then, how do I find oxidation? Because O
Peroxide में oxygen का oxidation state क्या है?
-1. Oh, yeah. Okay, I didn't consider that.
Okay. O2 will have 0 oxidation state.
Yeah, elemental state है वो इसलिए.
And how does Cl2 has -2? I got
Cl2
wait.
doesn't have -2. That you have to calculate. This I had
Cl
written
is
for oxygen.
Cl is +3.
So this would be -2, total of -4. So this will be +3. Yeah.
Because you wrote -2. I got confused.
No,
Acha,
I
that
had
is
written for
electrical.
oxygen. Yeah.
Ma'am, again, okay, no. So for oxidation will be -1 to 0, right? Because the chlorite ion mate does not change.
Yeah, correct. Ansh, Dhriti, Ishita, where are you guys at? I haven't heard from you. क्या केस solving, following, क्या हो रहा है? Are you getting it? Actually, you guys do one thing. So solve this, like do the balancing and send the pictures of your this particular balancing on WhatsApp. Then I will check. Okay.
So we solve the entire thing and just put it on the group.
Yeah.
In the
Okay.
group. Okay.
Yeah. You can put it on the group. So then I
Yeah,
can
yeah,
check it. Yeah.
got
So we'll
it.
end the session now. Aram se kar lena. If you want, I will send a PDF, like the PPT that I was using here. I'll send the PDF to you
Okay.
guys. So if you want, you can use that notes. Okay.
Yes, ma'am.
Okay, ma'am.
Okay. All right.
Yeah. Thank you.
All right. Thanks.